Good morning friends. Last we discussed about the periodic time of a spring and frequency of a oscillation of a spring. Right? Now the equation of periodic time of a spring P is equal to 2 pi under root of m upon T. K is the force constant of the spring, where K is equal to force constant of a spring. Now friends, in practical we also have to find out the force constant of a spring in experiment. So how we find out the force constant? As we know the periodic time and value of the mass suspended at the free end of a spring. At that time we are using this equation of period of oscillation of a spring. P is equal to 2 pi under root of m upon K. Now making the square on both sides, therefore T square is equal to 4 pi square m upon K. Therefore force constant of a spring is K is equal to 4 pi square m upon d square. M upon d square. That is the equation of the force constant of a spring for a single spring. Suppose that two springs are connected in series. So different cases are asked in NEET level exam and also good set exam. For that purpose, first, what is the periodic time of a spring? P is equal to 2 pi under root of m upon K. And using this equation, we find out the force constant of a spring. K is equal to 4 pi square m upon p square. Now, for series connection or the series combination of two springs, for series combination of springs, what is the equivalent force constant? For that purpose, if two springs of force constant K1 and K2 are connected in series, that means here the two springs are connected in series like to this manner. Here the one spring having the force constant K1 and other spring of force constant K2 is connected like this way. And at the free end, here the body of mass M is suspended. That is the rigid support. So what is the force constant or the equivalent force constant of these two combination of these two springs? Combination of these two springs. So an equivalent force constant of series combination is 1 upon K is equal to 1 upon K1 plus 1 upon K2. That means the K is equal to K1 K2 upon K1 plus K2. K1 plus K2. There is the equivalent force constant of series combination of two springs having the force constant K1 and K2. If K1 is equal to K2, is equal to k dash. Therefore, equivalent force constant K is equal to k dash square upon 2k dash. Therefore, k dash by 2. And periodic time of combination is T is equal to 2 pi under root of 2m upon k. So in this case, we can find out the period of oscillation of series combination of two springs like this way, having the first constant are same, that is the k. Now, what's happened if I connected in parallel? For parallel combination, of two springs, For that purpose here, if two springs of force constant K1 and K2 are connected in parallel. For that purpose here, for parallel combination, the figure is like this way. One spring having the force constant K1 and second spring having the force constant K2. Are connected with a body of mass m. Here the first constant K2, here the first constant is K1. Or this combination is also connected like this manner. One spring having the first constant K1 connected with the body, and body is connected with other spring. Other spring is connected with the rigid support. That means the body is oscillate between the two springs as shown in the figure 2. So there is also the parallel combination because this part is make the straight down. So both are same figure. So in that case, an equivalent force constant is K is equal to K1 plus K2. K is equal to K1 plus K2. Now, if K1 is equal to K2 is equal to K dash, therefore K is equal to 2K dash, and periodic time is T is equal to 2 pi under root of m upon 2K dash. Now listen here, the difference between these two period of oscillation is, here the periodic time is 2 pi under root of 2m upon k dash. Here T is equal to 2 pi under root of m upon 2k dash. M upon 2k dash. Now the one important thing is that the force constant of a spring is inversely proportional to its length. The first constant of a spring is K proportional to 1 upon L, length of a spring. There is. So these are the important equation for objective type question. Maybe asked in NEET and also the competitive exam, and the numerical may be asked. So here this type of the combination, parallel combination. There is also the parallel combination. At the both end of a both spring, body is suspended and free to oscillate. So there is the parallel combination. Or if the body is connected between the two springs and free to oscillate between these two springs, so here also parallel combination. So first constant K is equal to K1 plus K2, and period of oscillation T is equal to 2 pi under root of M upon 2K dash. Clear? Okay. Now, here the first illustration of this chapter. On an average, a human heart is found to beat 75 times in a minute. Calculate the frequency and speed. Yeah, 75 times beat take place in a minute. So there is the frequency is given. Therefore, frequency of beat frequency F is equal to 75 upon minute. Is equal to 75 upon 60 seconds is equal to 1.25 second per second of the second inverse. That is the frequency. And periodic time T, period of oscillation or period of beat, T is equal to 1 upon F. Already we derived this equation for the relation between the frequency and periodic time. Therefore, 1 upon 1.25 is equal to 0.8 seconds. So the periodic time of beat of human heart is 0.8 seconds. So this type of the objective question may be asked. Clear this? Okay. Now next illustration 14.5. That is the important because we have to find out the displacement, speed and acceleration of a particle performing the simple harmonic motion. The displacement of a particle performing a simple harmonic motion is given. X is equal to pi cos 2 pi t plus pi by 4. At time t is equal to 1.5 seconds, calculate the displacement, speed and acceleration of the body. So first, the displacement of a body is given. Of a body at time t is xt is equal to phi cos 2 pi t plus pi by 4. This equation is given. Compare with, there is equation 1. Compare equation 1 with equation of displacement of a simple harmonic motion. Xt is equal to A cos omega t plus phi. Therefore, A is equal to pi unit for the meter, because all quantities are given in SI unit system. Therefore, pi meter. It is pi meter. Comparing with this, now cos as it is, instead of the omega, 2 pi, omega is equal to 2 pi radian per second, and t as it is plus pi, and initial phase phi is equal to pi by 4. Right? Okay. So this type of the information is obtained by comparing given equation with a standard equation of displacement for simple harmonic motion. First we have to calculate displacement in time 1.5 second. Displacement at t is equal to 1.5 second. So how we obtain it? So displacement xt is equal to a cos omega t plus phi. Substitute value x at t is equal to 1.5 second. A is, what is the value of a? Pi. Cos here 2 pi, t is 1.5 plus pi by 4 is equal to pi cos here 3 pi plus pi by 4. Now we know that in trigonometric cos 3 pi plus theta minus cos theta, but we know that cos 3 pi plus theta is equal to minus cos theta. Therefore, our equation is minus pi cos pi by 4. And cos pi by 4 is 1 upon root 2. Therefore, minus pi upon root 2. Because the cos pi by 4, value of this is 1 upon root 2. Therefore, minus 3.535 approximate, that is the meter. X, that is the displacement. Now, the second physical quantity we have to find is velocity. Velocity at t is equal to 1.5 seconds. So we have the equation of velocity. T is equal to minus a omega sine omega t plus phi. Substitute the value of a, omega and phi. Minus a, that means the minus phi, omega 2 pi sine omega again 2 pi t 1.5 plus phi is pi by 4. Therefore, minus 10 pi sine 3 pi plus pi by 4. But we know that again sine 3 pi plus theta is equal to minus sine theta. Minus sine theta. Therefore, velocity at time t is equal to this negative minus 10 pi into bracket minus sine pi by 4. Minus sine pi by 4. This negative becomes the positive 10 pi. Here sine pi by 4 1 upon root 2. 1 upon root 2. Therefore 10 into 3.14 upon root 2 is equal to 10 into 3.14 upon 1.414 is equal to 22.2 meter per second. Check the answer. There is the velocity at time t is equal to 1.5. Now we require the value of acceleration at this time, 1.5 seconds, and acceleration at t is equal to 1.5 seconds. Now, what is the equation of acceleration? Acceleration of a simple harmonic oscillator at time t is at is equal to minus omega square xt. Minus omega square xt. Substitute the value at t is equal to 1.5 second. Therefore, acceleration at t is equal to 1.5 is equal to minus omega 2 pi square here. Xt, already we obtained the xt, minus 3.535 meter. Therefore, minus this minus plus 4 pi square into 3.535. So its value is 139.41 meter per second square, approximate 140 meter per second square. So there is a acceleration at time t is equal to 1.5 second. So this way we can find out the displacement, as a velocity and acceleration by using our equation. Already we obtained the equation of velocity, acceleration, and also we have the displacement. Clear this? Okay. So there is the velocity at time t is equal to 1.5. Now next numerical is 14.7. A block of mass 1 kg is fastened to a spring of a spring constant 50 Newton per meter. The block is pulled to a distance x is equal to 10 centimeter from its equilibrium position. X is equal to 0 at time t is equal to 0 on a frictionless surface. Right? From rest at time t is equal to 0. Calculate the kinetic potential and total energy of a block when it is 5 centimeter away from the mean position. Okay. Now first, we are going to understand what this numerical suggests. So here the block is lying on a horizontal surface this manner. That is the horizontal surface. One end of the spring is tied with rigid support like this manner, and at the other end the block is tied of mass M. That is the equilibrium position x is equal to 0, and that is at rest time t is equal to 0. Now the block is pulled up to the x is equal to 10 centimeter distance and released. So it performs the oscillation, simple harmonic motion between the x is equal to plus a to minus a, between these 2 points. When the block is at this position, x is equal to 5 centimeter away from the mean position, we have to find out at this point what is the kinetic energy, potential energy, and total energy. Right? So, what is given first? The mass of the block, M is equal to 1 kg. Spring constant, K is given as the 50 Newton per meter. Amplitude is 10 centimeters, is equal to 0.1 meter. And distance from the mean position is 5 centimeter, that means the 0.05 centimeter. To find out the kinetic energy, we require the angular frequency and also the displacement x. To find out the position, potential energy and kinetic energy, the displacement s and also the angular frequency required. And to do that is first we calculate the angular frequency of the block. omega is equal to under root of k upon n. K and m both are given, so under root of 50 upon 1. So under root 50 is equal to 7.07. Angular frequency, so its unit is radian per second. Radian per second, that is the value of omega. Now, next is we are going to calculate the position. Position is given, x is equal to 5 centimeter. From the equation of the position, we are going to calculate now what is the cos omega t and sin omega t. Therefore, the displacement at time t displacement of a block at time t is xt is equal to a cos omega t. A cos omega t. Now x is given, that is the 0.05. 0.05. A is also given, that is the 0.1 into cos omega t. Therefore, cos omega t is equal to 0.05 upon 0.1 is equal to 0.5. Therefore, cos omega t is equal to 1 by 2. Therefore, omega t is equal to pi by 3. That is the value of cos omega t, and therefore, omega t is equal to pi by 3. Omega t is equal to pi by 3. Now, we also require the value of sin omega t. Sin omega t. Omega t is equal to pi by 3. Therefore, sin pi by 3. Sin pi by 3, root 3 by 2. Root 3 by 2. And its simplification is 0.8661. 0.8661. So that is value of sin omega. Clear this? Okay. Now in kinetic energy is equal to half mv square. Velocity is also required. Therefore, velocity of a block, velocity of a block at time t. So that x is equal to 5 centimeter distance. So first the position xt is equal to a cos omega t, and velocity v is equal to dxt upon dt is equal to d by dt, value of xt, a cos omega t. So is equal to minus a omega sin omega t. That is the value of velocity v. Here is, now we substitute the value. Therefore, velocity of a block at x is equal to 5 centimeter distance is v is equal to minus a is equal to 0.1. Omega already we calculate. Omega is equal to 7.07, and sin omega t is 0.8661. 0.8661. Here is, therefore, the value of velocity is minus 0.6122 meter per second. Calculate and check it, the answer. Therefore, kinetic energy of a block is K is equal to, the kinetic energy K is equal to half mv square. So it's equal to half, m is given 1, and velocity we obtain minus 0.6122 whole square. Right? Therefore, 1 by 2 here, 0.3727. Therefore, kinetic energy is 0.1884, 0.1864 joule, kinetic energy. Now, potential energy. Potential energy. Potential energy U is equal to half kx square. U is equal to half kx square. Half k is already given 50, and displacement is 5 centimeter. That means the 0.05 whole square. Therefore, 25 into 0.0025 is equal to 0.0625 joule. That is the potential energy. And total energy, E is equal to kinetic energy plus potential energy. Kinetic energy we obtain is equal to 0.1864 plus 0.0625. So it's equal to approximate 0.2525 joule. So there is the total energy of the block tied with a spring, and there is the displaced by 10 centimeter from its equilibrium position. During its oscillation, when the block is 5 centimeter away from the mean position, at the time the kinetic energy is, potential energy is, and total energy is this. So first we calculate the angular frequency of a block. After that, the value of the cos omega t and sin omega t. Because we have the equation of potential energy and kinetic energy in terms of sin omega t and cos omega. Here is